All right. Take three.
All right, Greg, take it away.
All right. Well, first of all, Josh, thanks so much for inviting me to speak. It's always a pleasure to engage with the Federal Blockchain Working Group. Um, my full name is Lucius Gregory Meredith. For those who don't know, Lucius is the Latin for light. Greg is the Middle French, I believe, for vigilant, and Meredith is Welsh for watcher of the sea. So my full name means lighthouse. um, and so that's why you'll see my moniker Lighthouse all over the internet. But I use a German homophone, so it's Leithaus, Lighthouse. And I'm a mathematician and musician. I've been studying the mathematics of concurrent computation for a very long time. And that mathematics informs Microsoft's BizTalk process orchestration, which has been uh, in the uh, in the enterprise sector for a good 20 years now. And I was also the founder and president of Archain Cooperative from 2017 to 2022, a souped up and improved version of the mathematics under BizTalk is under Archain. And now with Firefly, we have dramatically improved the offering yet again. And I'll talk a little bit about how that applies in the artificial intelligence domain. So with that introduction, I'm going to dive into the slides. So there are lots and lots of groups, even though Archain is now, yes?
I apologize to interrupt, but your slides are cut off on the left and right.
Oh,
Is there a way to either maybe zoom out or present in landscape?
it was in landscape. So how
Oh,
about I just do, is it cut off in left and right now?
it's cut off on the right now.
Huh.
Maybe
Do you want a screen share? And you have the slides.
I can't access them through the VA firewall.
Oh, got it. Understood.
Maybe just present in full view, and then
I was in full view. How's
I,
that? Is that less cut off in the right?
it's still kind of cut off. I meant as far as instead of zooming in, present it's sort of like in the page view that you had before.
Okay. All right. I'll go back to that view. Then it'll be cut off in the left and the right.
I meant where you could scroll up and down and you can see the full your full document.
Oh, okay. That's where I am now. I can do that. Is that better? Can you see this full slide now?
It's still cut off on the right.
How about that?
Yep, that works.
Okay. So I'm just going to do that much so I can see the writing on the slides.
Oh, perfect. That's
Okay.
perfect. Thank you.
All right. Great. Sure. No, I appreciate the you identifying the difficulty. Okay. So even though Archain ended its life in 2022, the technology was open sourced and lots of groups have picked it up. So there's Ronix Labs, Concursus, and Row Vision. But the Firefly is the actual successor to Archain. And we can talk about why that is in a little bit. But one question that you might be asking is what makes this technology so popular? Why are projects picking it up? And we can kind of broadly categorize the benefits in terms of four categories. It's scalable, and what we mean by scalability is that you don't give a single number per se. You're able to add, like I think Solana was advertising a single number, 30,000 transactions per second. But if you're scalable, it's not about a single number. It's about how you grow with respect to adding hardware. So Archain, as of January of 2021, was getting about 1,000 transactions per second per node per CPU. So what that means is that if your community needs 10,000 transactions per second to serve its network communications transactions and data storage, then it would need to roll out a network of at least 10 nodes, and each node would have to have 10 CPUs per node to get the 10,000. If your community needed 100,000 transactions per second, then it would need to roll out a network of at least 100 nodes, and each node would have to have 100 CPUs. So that's what we mean by scalability. And by the way, that's how we've been scaling software for the last 50 years. So the way we scale software systems is by adding hardware. And if your software architecture doesn't get faster, doesn't take physical threads and turn it into performance and throughput, then it's dead in the water. You may not know it, but that's been the new Moore's law since about 2005, so roughly 20 years. What the hardware vendors have been providing us is more physical threads per cubic centimeter at lower cost and lower power consumption. So if you want to be on track with how the hardware is tracking, then what your software does is it eats physical threads and turns that into performance. Speaking of which, what do you do with that performance? Well, one of the things that you can do is you can store data directly on chain. Now, I know people have been sort of trained to say, wait, why would you ever want to do that? Well, you wouldn't ask that about a storage medium like SQL Server or Oracle any of the open source SQL databases. I mean, it's totally natural to store the data on the storage medium, and the blockchain, when it becomes scalable enough, becomes a storage medium. But also from a business perspective, if you are putting the data behind a private firewall that is not going to be actually decentralized. in fact, I have often laid awake at night imagining, what if the GitHub folks were more gangstery, right? And they sent out mailings to the really, really hot repos and said, we think your code is important to you. It'd be shame if something happened to it, right? And in fact, when Microsoft took over GitHub, one of the nation states, which shall go nameless, ended up on the OFAC list, and all the repos from developers in that region of the globe suddenly lost access to their code on GitHub. So it's not quite so far-fetched as it might seem. And of course, once you store data on chain, you'd like to be able to search it. And in this regard, I think it's really important to understand that search is what created the global economy. Yes, there were lots and lots of logistics and physical things that had to happen, but when the sort of compute infrastructure available to the average citizen was such that on a 24/7 basis, with their mobile devices and laptops and desktops, they could search for jobs, they could search for employees, they could search for reviews, analysis, et cetera, et cetera, et cetera. That's what created the global economy. Suddenly, resources from all over the world were directly accessible. And so search is of essential value when we talk about the internet economies. And the blockchain architectures currently are a step backwards. So if you compare, say, OpenSea's architecture, where the data is stored on IPFS, which is a non-searchable storage behind a non-searchable blockchain, that is, in fact, a step away from the very thing that created the global economy. And there are all kinds of things that OpenSea has to do, because when artists mint NFTs on OpenSea, the first thing they ask is, how do people find my work? So this is a real issue, and you need to be able to search your blockchain. The Firefly capabilities, which are centered around the concurrency provided by the smart contracting language Rolang, um, uh, it not only is providing this ability to eat physical threads and turn it into performance, it's also a transactional query language. So in many ways, it's the successor to SQL. And what it really does is provide the best of both relational and NoSQL databases. But even beyond that, we provide automated detection of a variety of um, the kinds of issues that you would need to deal with if you were actually deploying mission critical systems. So if we're attempting to replace the world's financial systems, then you'd need to be able to catch bugs like security leaks. You'd need to be able to prevent unauthorized transactions and things like that. And so the the spatial behavioral types that are available for Rolang prevent those kinds of errors and many more. Now, we kind of advertised this talk as about blockchain and AI. So the question is, what does all this have to do with AI? And so one of our customers is SingularityNet. They have made a commitment to providing to their community and, in fact, the globe, decentralized AI solutions. And like many companies that are really at the forefront of artificial intelligence, they have concluded that artificial general intelligence is not the same as large language models. At a minimum, you can go and listen to Ben Goertzel, and he's pointed out that at a minimum, large language models plus symbolic reasoning is going to be necessary. But in fact, he believes, and I think rightly so, I think the clinical data supports this, that there are basically lots of specialized components in the brain, just like there are lots of specialized components in software for doing various kinds of reasoning. And you need something that enables you both to express some of that reasoning and to glue together the specialized components. So SingularityNet has developed a language called Meta for doing just that. And to be honest, like the SingularityNet folks, they're all AI geniuses. If you get them talking about AI, they can provide you lots and lots of insight, but they got dragged into language design kicking and screaming. That wasn't their bailiwick. That wasn't really their expertise, and it is hard. I won't kid you. Language design is a non-trivial problem, and they know that if they want to scale both their AI solutions and the execution of the meta language, they have to go concurrent, right? Because that's how you scale in today's systems, but not just in today's systems, but also in the human brain and in nature in general. Concurrency is the name of the game for scaling. But concurrency is scary. If you go look at the data on how programmers fare against solving concurrent problems, even concurrent problems they have already solved before, it is truly terrifying. And that's why that's why sort of the internet landscape is the way it is. I won't go into that in this talk, but there are good reasons for why we see the sort of architectures that we do when people do brute force approaches to concurrency. So for SingularityNet, they've chosen to go a different route, which is to take the concurrency tools provided to them by Firefly and Rolang and to effectively translate their meta language and their architecture into Rolang. And that gives them not only the concurrency they need, but a lot of the protections against the sorts of errors that that come up when you're doing that sort of thing. Now, on the Firefly side, what we needed to understand was exactly what the language meta is and what it does. So, like I said, you know, the Singularity Net folks, they're not language designers by trade. They've sort of become language designers out of necessity. And they had a couple of good reference implementations, but they didn't have what we in the business call a proper spec. So the first thing we did was to provide an operational semantics for meta. So sort of the gold standard for presenting a language is you have some grammar that says what are all the syntactically correct programs. You have what's called a structural equivalence. So meaning that there are some kinds of syntactic differences that don't make a difference in terms of execution. So for those programmers in the audience, you know, if you write a function, say f, that takes some argument, say x, and then you have some code that uses the argument x, then the execution doesn't change if you were to globally replace x for y, assuming that y wasn't already used by the program in some way. So if y is sort of independent of the program variables, if you globally replace x for y, then it's the same program. So that's you know, the common sense description of what we in the business call alpha equivalence. And so you have your grammar, you have some structural equivalence, and then you have what are called the structured operational semantics, which are a bunch of rewrite rules. They say, you know, if the program and whatever state you have that's necessary to execute the program looks like this, then you transition to a program that looks like this and maybe modifying that state. So we're starting to get to how this relates to blockchain. We actually didn't just provide them with one operational semantics. We provided them with two. So the first one pretty much just covered what their reference interpreters did. And in fact, just a side note, when I produced the paper, then one of their very bright developers took the paper and just implemented what's in the paper and nothing else. He just translated the math into code and then ran their tests against the code, and their tests worked. Like, that doesn't ever happen in software, right? It never just works. And in fact, there was one test that didn't work, and I'll get to that in a moment. But that was pretty much a software miracle. So what that said was we accurately reflected back to them in math what their language does. But then we also ran a little algorithm by hand that took that operational semantics and added the notion of gas. So those of you who are familiar with Ethereum understand that in order to be secure, to sort of run your node outside of a firewall, then you have to deal with a lot of security issues. And one of them is denial of service attacks, right? So if you have public-facing APIs, internet-facing APIs, then the tradition is to protect those with tokens. And by the way, I just want people to understand, because I don't think a lot of people do, that tradition is much older than the blockchain. So at least since 2005, companies like Microsoft and Google and the New York Times and the Guardian and yada, 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 have been protecting their APIs with tokens. Ethereum's big idea was not to protect their nodes with tokens. Their big idea was that the tokens should be cryptographic. And so it's a much, much smaller delta than people might think. And so if you don't believe me, just go to the Google developer page and see that you can not only get tokens from the Google developer page, but you must have tokens in order to run APIs against the Google, to run the Google APIs. So what we did was to effectively tokenize the meta operational semantics. And by the way, that is completely algorithmic. There's nothing magic about that. And in fact, the algorithms go back to results on rewrite systems that are over 50 years old. So again, people should be aware that this stuff has been well understood. And if we understood these results in the right way, then a lot of this stuff becomes cookie cutter, right? It becomes completely algorithmic. And as a result, you can provide value at a much lower level, which I'll talk about in a second. So essentially, we provided them these two operational semantics. One was, this is how your language works, and this is how your language has to work if it's going to run on the other side of the firewall, on the public side of the firewall, right? If you want to actually develop decentralized artificial intelligence solutions, this is one of the steps you have to take. More generally, I just want to talk a little bit about how the level at which Firefly is delivering value to the community. I described this taking an operational semantics and running it through an algorithm and getting a version of the same operational semantics where you've tokenized it. You've required that in order to take a step or take a computational step or do some storage, you have to have gas. For purposes of this talk, we'll call that the indecent algorithm, right? As in making it into a decentralized algorithm. There's another algorithm that Firefly provides, and it's again at the same level. You give us an operational semantics, a description of how your model of computation works, and we will produce a type system, a spatial behavioral type system for it. So that's how the Rolang spatial behavioral types were developed. So the paper called Namespace Logic, which I published in 2005 at the Trustworthy Global Computing Conference. So that was produced by running this algorithm by hand on Rolang. But in general, the algorithm it can be completely automated. And so what we're suggesting is that there's a level at which you can come in much lower than the Ethereum ERC20 tokens level or general smart contracts level. What we're saying is that you can automatically produce a layer 1 chain using these algorithms that best suits the needs of a particular community. So if your community is really into JavaScript, we can take our algorithms and produce a version of JavaScript with gas and produce a version of JavaScript that has spatial behavioral types. And by the way, these types catch a lot more than, say, the types in TypeScript or the types in Dart. And it doesn't take us tens of millions of dollars to produce brand new versions of JavaScript and get them adopted by the internet. You press a button and you get this version. And by the way, at least the gas and the behavioral types, that's a minimal set of features defensible, for a network to be defensible in mission critical settings like supply chain or finance or things of that nature where you might have loss of life or significant loss of property. So if you want to deploy these kind of decentralized solutions, that's the bare minimum you need in order to do that for real and not fall over. So again, let me just give you a picture of what I'm talking about. We can imagine that there's a decentralized deployment of meta nodes. So let's say that there are a few nodes running in Dubai, some nodes running in Shanghai, some nodes running in Seattle, and some nodes running in London, right? And the whole collection comprises the current public deployment of the Meta network. Then the tokenized version of the operational semantics is going to defend against denial of service attacks. So the bad actors, so just to be clear, right, the way Ethereum and all of these smart contracting platforms work is that a computation done by one node is done by all of the nodes. And what the consensus algorithm does is to make sure that they all agree essentially on the initial state and the final state. There can be variances in the actual computational steps, but the state of the data store, the state of the chain, so to speak, at the beginning and the end of the execution of the smart contract, everybody in the network has to agree on that, and that's what the consensus algorithm is providing. So if one of these bad actors says, "Hey, I would like you to compute all the digits of pi," then not only this node, but all the nodes in the network are going to start computing the digits of pi. And that's a terrible thing, right? Because with one attack, the entire network is brought down. And so what you have to do is you have to say, hey, you know, for each computational step, at least at the logical level, you got to pay some gas. And so since the supply of gas is limited, these characters can't bring down the network in that way. Nash Foster, whom I've worked with in the past, he says, these guys have to make everybody else rich if they want to bring down the network. That's another way of thinking about it. So that's when you're coming under hostile fire. When you're coming under friendly fire, people make mistakes. So they write smart contracts that leak information. They write smart contracts that deadlock. They write smart contracts that have a number of safety and liveness issues. And we need to defend against that as well. And the spatial behavioral types provide defense against friendly fire, which is kind of the dual to defense against the hostile fire. So this is the kind of architecture that we're providing for SingularityNet. And what's notable about the way this is done is that armed with the operational semantics, we can then provide a translation into Rolang that is correct by construction. So what does that mean? It means that we built the translation. So get this, it's a little bit recursive. We built the translation from the proof of its correctness. There's a correspondence between the code and the proof of its correctness. So what I've given you is the high level pieces of all the things in the paper that went out as a part of the pre-communications to this talk. So if you go to the archive paper, you'll see exactly those things. So you'll see the specification of the operational semantics, the specification of the operational semantics with gas, and then the translation to Rolang, and then the proof of its correctness, and the discussion about how the code derives from the proof of its correctness. So if that isn't enough in terms of the value proposition, let's add a couple of more things. One of the things that we did was in the case of the test that didn't work, we analyzed the test and we realized that they were leaking information. That in order for the test to run, the semantics of Meta had to leak information. And so we provided with two solutions. One was the original operational semantics that we provided, which didn't leak the information. And they didn't like that because that eliminated certain kinds of computations which they thought should run. And so we said, okay, well, if you want those to run, then you're going to have problems where information is leaked all over the place. How about we introduce a new piece of syntax so that people can seal off information if they need that to be sealed off? And they liked that idea. And in fact, in general, we provided not just one, but three different language constructs that enrich their semantics and make it possible for them to be on the cutting edge of these kinds of languages for doing symbolic reasoning. And that's what's going into the version of Meta that Firefly is providing for SingularityNet. And I just want to say that their type system, which was very cool and clever for AI applications, was terrible for dealing with the kinds of issues that you get with concurrency. And so we can employ this OSLF algorithm for generating type systems to give them a type system which will enable them to provide these sort of prophylactics against or defense against friendly fire. And moreover, when you stand up a Firefly network, you give it a wallet.txt file, which is effectively minting tokens for this denial of service capability, prevention of denial of service capability. And so the SingularityNet tokens that are for their meta networks are essentially just these tokens, but instantiated for this particular network. So they get all of that gas stuff for free, right? So we told them this is what your operational semantics has to look like, but guess what? You don't actually have to implement it that way because you have translated everything into Rolang, and Rolang is running inside a container that does all that for you. You get that at the layer 1 level in your network instance, just as a result of running on top of Firefly. So then the last little bit of the talk here is, how do, if we step back from the details of providing this kind of infrastructure for a decentralized AI, then we have to ask, how does this fit together in a way that's economically sustainable? So I just want to point out that the large language models like ChatGPT or GPT-4 and its successors, they've all been trained on data that was appropriated from the internet. So once again, people on the internet have blissfully provided a ton of value to customers like OpenAI, in much the same way they provided value to Facebook and Twitter and many other companies that have made a lot of dough off of user content, user-generated content. And the users are not seeing anything like the participation in the economic engine, right? Online advertising is the largest economy in the world. It surpasses oil, right? And users just do not see anything like the billions per quarter that these companies clear. This is post taxes, post expenses, the billions that they clear from using user-generated content. So the users are not involved in that economic proposition at all. And that's one of the reasons why the creative class is very, very much at risk. And I think we've all seen that transition in society. What's going to happen in the next phase is that they're very, very savvy data set providers. So Pfizer, Lilly, AstraZeneca, they have data sets that it's going to be very useful to train large language models on. But Pfizer and Lilly and AstraZeneca, those companies are not going to give up those data sets for free. They're gonna want to be compensated. Likewise, it is just not economically feasible for OpenAI or any of these large language model networks to continue to offer their services for free. That isn't going to be sustainable over time. And so they will have to somehow be compensated for offering that much compute to that many people. And then finally, we believe that there are going to be like SingularityNet, that the real value, the place where you start to see actual intelligence and other kinds of value, is when you bring together specially trained LLMs and other kinds of components like SAT solvers, et cetera, under at an integration point. and those integration points will also need an economic proposition. And so the question is there an ecosystem where everybody wins? And we believe that if you wrap them up in these networks, these tokenized networks, like we've described in a little bit more detail for Meta, that you begin to have the makings of an AI marketplace, right? So if you wrap up your data sets in a tokenized network, you wrap up your LLMs in a tokenized network, and you wrap up your integration points in a tokenized network, then you have the basis for a marketplace where everybody wins. Now, obviously, sort of downstream, this network is paying that network, or this network is paying that network, or this network is paying that network. But over here on the edge, where you've got just ordinary Joe and Jane blogs interacting with a network, they're used to free, but they're also used to sponsored content. So you can also tokenize advertisement. You can just follow Web 2.0 and just add tokenization to it. And then, when they issue queries to the network, unless they're paying a subscription, they get back sponsored content along with the answers to their queries. But in the tokenized network setting, something becomes interesting. What is that? Well, it might be that they consume more sponsored content than actually they need to consume in order to match the economic burden of their use of the system, in which case they're actually earning tokens as opposed to just seeing content, which then can feed back into the ecosystem in a certain way. I think you can kind of see the picture. It completely changes the adoption model. So with that, I'll conclude. One of the reasons we call ourselves Firefly is because what we need globally to deal with the sorts of things that are coming down is a kind of synchronization that we see in fireflies, where it's not just a single flash of insight, but it's another and another and another until billions of them are magically firing in synchronization, and that illuminates the way forward. So thanks again for giving us the chance to speak. Any questions or comments?